So let's start here with just a little bit of review. Thank you, Grace. And as Grace just demonstrated, if at any point like you're having trouble seeing because I don't have the lights off and it's like, yeah, I can't see this very well, you are more than welcome to do what Grace just did and walk up and just turn the lights off. You don't have to ask, you don't have to say anything. Just get up and take care of it. It's no big deal. Sometimes I just get going and forget to do some, just forget. Sometimes you forget, you know what I mean? It's okay. Not a big deal. All right. So what I want to do here is I want to start with a little bit of review ideas before we dive into chapter 7 stuff, because there's some content from way back into early first semester geometry that is kind of necessary here. And it's really important to kind of draw a distinction between those techniques and these new techniques that we're going to develop inside of chapter 7. And it's been a long time from first semester that we did this stuff, and it's been a really long time since geometry when you would have done these things. So I think it's probably best to take a few minutes and just make sure that we're all kind of on the same page. Okay with that? So this isn't technically chapter 7 stuff yet. I'll make sure I make a distinction of when that kind of starts. But this is just kind of like review. Okay. So one of the key ideas that we talked about in first semester and in geometry is what can we do with a right triangle? Yes? Okay. So in a right triangle, let's say this triangle has sides has angles A, B, and C. Typically, we name angles with capital letters. And then we would name the corresponding sides with lowercase letters. So the side that's opposite this angle A would be this one. And we'd name that with a lowercase letter A. The side that's opposite the angle B is this one. We name that with the lowercase letter b. And the side that's opposite this angle C is this one. We name that with the lowercase letter c. Everybody okay with that? Just kind of like a naming convention, but it's important that we understand how we're naming things so that, when we write a formula, we're being consistent about that. Okay? So far, so good? So let's think back to geometry or first semester and tell me some things that are true if we have a right triangle. Sure. Okay.
A squared plus b squared equals c squared.
Well, be careful.
A squared plus c squared equals b squared.
Yeah, in the picture that we've drawn, we would say a squared plus c squared is equal to b squared. Again, the sum of the square of the leg should equal the hypotenuse squared. That has a name. Does anybody remember the name for that?
Pythagorean Theorem.
Yeah, that's the Pythagorean Theorem. And that's named after a Greek mathematician, Pythagoras. It's actually, he wasn't the one that discovered it. He had like a religious society that's like worshipped numbers. And because he was the leader of the society, he kind of got credited with naming rights to this theorem that was quite clear through antiquity that existed prior to him and his society. But That's great. Okay. What else can we say about right triangles specifically? There's one other big thing that we would have used in first semester. Yes.
Is it like SOHCAHTOA?
That's exactly what I'm hunting for. Exactly, yes. So remember, SOHCAHTOA is an acronym. What does that acronym really stand for? Yeah, it tells us the definitions of sine, cosine, and tangent inside of a right triangle. So this is my triangle, and the angle theta is that angle that I've drawn in there. The opposite side would be this one, the one across from the angle. The adjacent side is one of the arms of the angle that is not the hypotenuse of the triangle. And then the hypotenuse is just the hypotenuse for the triangle, right? Is that all ringing a bell? So one of the things that we would have asked you to do in your geometry class would have been things like solve the triangle. So when we say solve the triangle, it means that we want to find, we need to give, let's do that. We want to find all the unknown angle measures. So in this triangle, that would be angle B. And we want to find all the unknown side lengths. So that would be side length AC and then side length AB. Just ringing a bell as a familiar looking task anyways. Let's start by finding that angle B, because that's pretty easy to do. How can I find the measure for angle B?
Add 43, 90, and then subtract 5.
Okay.
Or 180 minus that.
Yeah.
Positive.
And then, Joe, why 180 degrees?
Because it affects the total degrees of the triangle's 180.
Correct. Yep. Yeah, we'd say the sum of the interior angles. For a triangle is 180 degrees. Excellent. So that's really easy, right? How are we going to find the side length here? Which side length do you want to look for first? Let's pick one. You want to find AC first or AB first?
Let's go AB.
Let's go AB. Does it matter?
I think so.
No, it doesn't matter which one you choose to do first. You can do them in either order. Not a big deal. So let's say we're finding AB first. Right? That's what you said? Or did you say AC? I don't remember
It's an
anymore.
AB. 'cause,
AB.
like, the letters are in order.
Sure. So we'll find AB first. So first thing I'd want to do, now that I've chosen a side length, is to pick an angle to use. Either I'm going to use the 43 or the 47. Does it matter which one I use? No. Let's say we're going to use the 43. Okay. Relative to that 43 degrees, the side that we know is opposite, adjacent, or hypotenuse.
Opposite.
So this is opposite.
So do we use side?
The side we're looking for, AB, is opposite, adjacent, or hypotenuse. Hypotenuse. So we have opposite, we're looking for hypotenuse, we should use sine. So we can say sine of 43 is equal to opposite over hypotenuse. Everybody good with how I set that up? Now to solve for AB, notice that AB is in the denominator of the fraction. So the first thing I'd want to do is get that out of the denominator. How would I do that? Absolutely. I multiply both sides by AB. So that's like AB times sine 43 is equal to 10. And then I would, gotta get AB by itself.
Divide by sine.
Divide by sine 43.
To both sides.
Yep, exactly right. And then it's calculator time. Everybody good? So what thing do I have to be careful about when I go to do 10 divided by sine 43 into my calculator?
Is it like when you have to keep it at a certain mode?
Yeah, I got to be careful about what the mode is, particularly since last semester we've been flipping and flopping back and forth between degree and radian mode. Which mode should my calculator be in for this problem?
Degrees.
Degrees. Why degrees?
Because we don't need another.
Because the angles were measured in degrees. It was a 43-degree angle, not a 43 radian angle. That would be a crazy angle to have in a triangle. So we need to change that to degree. And then I'll just do 10 divided by sine 43. So I get 14.66-ish. Everybody good? Now, one thing I would do here, real quick, as a kind of a check, I know that the hypotenuse is AB, right? What do I know about the hypotenuse of a triangle? It's the longest side. So I'm going to check real quick and make sure that 14.66 is bigger than any other the sides that I know. It is. So that's a good sign. Everybody good? Doesn't guarantee that I've done it correctly, but it can certainly identify if I've done it incorrectly right away. You know what I mean? Okay. Now, let's find the other side, AC. How can I do that? So there's two feasible ways to do it. One way I can use the Pythagorean theorem, since now I know two of the three sides. So I can do AC squared plus 10 squared is equal to 14.66 squared. Everybody happy there? So to get the AC by itself, I'm going to start by subtracting the 10 squared. Note that I can't do 14.66 squared minus 10 squared and call that 4.66 squared, right? I have to square before I do the subtraction. Now you could do that manually on your calculator or whatever and get the number. I'm just going to leave it like this and do the whole thing in one shot on my calculator. Is that okay with you guys? But if you wanted to make like intermediate whatevers, that's okay too. And then the last thing I need to do to get the AC by itself is I have to get rid of the squared on there. How do I get rid of a squared?
Oh, what's it called? Square root it.
Square root it. So I square root both sides. Note that the square root of 14.66 squared minus 10 squared is not 14.66 minus 10. That the square root doesn't distribute. Everybody's okay there? So this is what I'm going to type into my calculator. So you guys can see it. So I'm using that answer function to just copy this 14.66 or whatever in there, rather than just typing 14.66. It was less buttons, that's why I did it that way. So I get 10.72. So that's one way you could have done this. What's the other way that I could have solved for AC? Yeah, exactly. So relative to the 43, let's say we're using the 43 degree angle still. AC is adjacent. And we know the opposite. So we could use, say, tangent in this case. We also know hypotenuse, so you could use cosine as well. That would not be wrong either. And then just like before, I multiply both sides by AC. And then divide by tan 43. And if I go to my calculator, I got the same thing, 1072. Feel okay here? Okay. The only way this problem could get different is if I give you different starting information. So there's two kinds of starting informations I can give you. I can give you, aside from the right angle, I can give you a one angle and one side length, like we did here. Right? I gave you the 43 degrees and the BC is 10. The other starting information that you could get would be to get two side lengths. Okay, so let's do an example here where you're given two side lengths. So again, just like in the previous problem, it doesn't really matter which piece you want to try to solve for first. Typically, or what I would do in this case is I would find AC first because it's pretty easy to do that. What do we need to do to find AC? Good, the Pythagorean Theorem. So what equation am I going to write there?
8c squared plus 10 squared to 17 squared.
Excellent. So again, the key here was recognizing that the hypotenuse is the piece that has to be by itself in the Pythagorean theorem, right? Easy to kind of overlook that if it's been a minute since you've used this tool, but that's again why we're doing this review real quick. So again, we subtract the 10 squared from both sides, and then square root both sides. And we go to our calculator. And we have 13.74. Everybody happy there? Pretty easy. Now comes finding one of these angles. Does it matter which angle we look for first? Heck no, right? So let's just pick one. Do you want to pick A or B? B. Does it matter? Of course it doesn't. But relative to B, what is 10? Opposite, adjacent, or hypotenuse? Adjacent. And what is the 17? Opposite, adjacent, or hypotenuse? Hypotenuse. So which trig function should I be using? Cosine. So I'm going to say cosine of B is equal to adjacent over hypotenuse. So far, so good. Now, how do I get rid of that cosine piece in front of the B so that I can get the B by itself? Because that's what we're looking for, right, is the value of B.
Divided side by cosine?
Well, cosine's an operation, so that'd be like I'm going to get rid of the square root symbol by dividing by square root sign. Like, that doesn't make a lot of sense. But we do need to cancel it out somehow. Division, though, is not the operation that's going to get rid of that cosine.
Multiplication.
Not multiplication. It's a function that we used last semester. It is cosine inverse. So we're just going to do cosine inverse to both sides. Everybody okay with that idea? Remember, the inverse trig functions, when you do one of these sine inverse, cosine inverse, tan inverse, return you an angle measure, right? B was an angle measure, so it makes sense that we have to use one of the inverse trig functions to get that. Everybody still good? So I did cosine inverse of 10 over 17, gives me 53.97. And then how should I find angle A then? Excellent. Hello, Tyler. How are you?
As good as I can be.
Okay. Well, anywhere you'd like. That's almost your seat from first semester, right? And just FYI, we've already set up the shared OneNote. So there's a link on the My Notre Dame page to do that. If you run into problems, ask Aaron or Becca or somebody here next to you, and they'd be happy to help you get through the rest of the way, because we just did it a few minutes ago. Oh yeah, we need to, what is that number? 180 minus 90 minus answer 3603. Everybody feel good? Okay. So if we're trying to solve a right triangle, really it's going to fall into one of these two cases, right? Either you're going to have an angle and a side, in which case we do what we did in the first one, or you're given two side lengths, in which case we do what we did just right here. Now here's the question. What about non-right triangles? Right? Can we still do these same techniques that we used here for non-right triangles? No, we cannot. So we have no Pythagorean theorem. We can't use that. And we have no SOHCAHTOA. We can't use that. We still have that the sum of the angles is 180 degrees, but we lost those two tools. Those two tools are both require right triangles. So chapter 7 is going to give us the answers of what we do in that case. Okay. So there are two tools here. The first tool is called the law of sines. So for any triangle, the following relationship holds. Our second tool is the law of cosines. So again, for any right triangle, the following hold. Okay. So the question here now that we should have is, okay, how do I know which one to use? I get that if I don't have a right triangle, I got to use these things now. Okay, fine. Well, how do I know which one I should be using? Does it matter which one I should be using? The answer to that is yes. Depending on the information that you've been given is going to dictate which one of these we should be using. Everybody's okay so far? So if you guys think back to your geometry class, one of the things you talked about when you talked about triangles was triangle congruence and triangle similarity. Do you remember those terms? They would have been something you spent quite a bit of time on, you doing the proofs and whatnot for that. If you remember, the triangle congruence and triangle similarity theorems were often named with like 3 letters, right? For example, you had side angle side was a type of triangle congruence and similarity. Those terms are the same terms I'm going to use here to differentiate of like when we should be using the law of sines or when we should be using the law of cosines. Okay with that idea? So for the law of cosines, we do that for side angle side situations and side 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 situations. I'm going to put a little asterisk there on the side 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 situation because there's something we need to check there first before we dive right into that. Everybody's okay with that? For the law of sines situation, we do that when we have angle side angle, angle angle side, and then side side angle, but I'm going to put a little asterisk there because that's a situation where we have to be a little bit careful also. Now, hopefully, we're writing these down. You see side side angle and you go, wait a second, Mr. Kulik, that was definitely not a triangle congruence or similarity theorem. I remember because there makes a swear word and that wasn't one of the theorems. And you're right. And the reason that this has the asterisk by it is because that situation you can get more than one answer. Oh. Weird. Okay. And that's why there's no triangle congruence theorem, because you're not guaranteed that, like, okay, if I have, these 3 things congruent, then I'm guaranteed to have congruent triangles. No, you could have 2 different triangles. Weird. Okay, that's fine though. looking at the time, this feels like a good place to stop. I'm not sure I want to get into examples right now. Let's stop here, and we'll get into some examples, pick up where we left off here next time. Sound good to you guys? Yeah, I think that sounds about right. I don't have any homework that I'd like for you guys to do because we haven't done enough. We spent most of our time here today kind of reviewing these older topics, which is great. I think necessary that we really make a big differentiation about like how we'd solve a right triangle versus a non-right triangle and make sure that it's clear that like these techniques we did here, we can't use here. But this feels good. I'm glad, I'm happy with what we got through today.